Mr. Ahmed here. Goal for today is to solve quadratic equations by graphing. So we've already gone over graphing our quadratic functions. Our goal now is going to be to start solving them. In order to solve a quadratic function, we're going to solve for x. That's really what we're trying to do. We want to find out what value of x makes the equation equal to 0. So standard form again, ax squared plus bx plus c. In our solving, it's equal to 0. On a graph, x is equal to 0 when it crosses the x-axis. So those are called x-intercepts. So we're going to find when it crosses the x-axis. The roots, zeros, x-intercepts, those are all the same term. A root is a solution, a zero is a solution. The reason why we're saying 0 is because the equation is equal to 0, and that is also where the x-intercept's actually occurring. So these are the solutions to the quadratic equation. So, steps to solve. The first step is going to be to graph it. All right, after you're done with the graph, we're going to find the roots, or those zeros. We're going to look for the x-intercept, and that is where it crosses the x-axis. And again, it points out these should be the points where the graph crosses the x-axis. This can occur three different ways with a quadratic. Case one, we could have two solutions. All right, this one's a little bit tougher to see. I'm going to zoom in here real quickly so you can get a little better look at this graph. So if we take a look at the parabola, the vertex is down here and it's opening upward. And it crosses our x-axis 2 times. The two places where it crosses the x-axis are the two solutions. All right, so this equation has two solutions. We graphed it for you. The original equation was y equals x squared plus x minus 6. It has two solutions. One of them is when x is equal to -3, because it crosses the axis at -3. And the other one is 2, because it crosses the x-axis at 2. So that is the case where there are two solutions. It crosses the x-axis twice. Zoom back out. The next one's a little bit easier to see. Next case. If it crosses the x-axis at one point, that would be the vertex. The vertex is going to touch the x-axis just at one spot. Now it's kind of hard to tell when you look at it, but take it for granted. It's just touching this x-axis at one spot, the vertex of the parabola. So that's its lowest point in this case. So our one solution is when x is equal to 1. X equals 1. And the final case could be no solutions. The parabola doesn't touch the x-axis at all. Its vertex is above the x-axis and it opens upward. It will never touch it, therefore there is not a real solution. So no solutions. All right. Those are our three possibilities. We can either have two solutions, one solution, or no solution. And we'll know that it's going to be one solution because the vertex is going to be touching the x-axis. Next page. So, for us to do these, our process is going to be to first graph the equation. So we have to use all the steps that we did the other day. First step, identify a, b, and c. A is equal to 1, that's the coefficient of x squared. B is equal to 4, and c is equal to 3. First, we have to find the axis of symmetry. X equals negative b, so that's negative 4, over 2 times a, 2 times 1 is 2. So we have negative 4 over 2 is negative 2. So our vertex, x value is negative 2. Have to plug it in to find y. When you plug it in, you'll get negative 1. So negative 2, negative 1. Plotting our points. Negative 2, negative 1 is the vertex. Highest or lowest point. I'm going to plot that right away. Left 2, down 1. Now we have to pick some points bigger and some points smaller. So the smaller ones, negative 3, negative 4. Bigger ones, negative 1 and 0. When you plug those in, when you put in negative 3, make sure you use parentheses. I'm not stepping through each one of those at this stage. Negative 3, we get 0. At negative 4, we get 3. You have to plug x in. Make sure you use parentheses. When we put in negative 1, we get 0. When we put in 0, we get 3. So when I plot the points, I see my solutions because y is equal to 0. That's where it's going to cross the x-axis. So when I go over negative 3, 0, there's one of my x-intercepts. And then I also have negative 1, 0. There's my two solutions. So my roots are negative 3 and negative 1. We found our two solutions. I'm going to finish graphing just to make our nice parabola. Good practice. Left 4, up 3, and according to the axis of symmetry, our vertical line here, 2 away, 2 away. Draw a nice U. It is not a V. And we have drawn our graph. All right, one more. Finding the solution. For us to solve, first step to the graph, find the axis of symmetry. X equals negative b. Oh, I didn't label a, b, and c. A is equal to 1. B is equal to negative 6. C is equal to 9. So negative b, we'd have a negative 6 over 2 times a, which is 1. 6 over 2 equals 3. So x equals 3 is our axis of symmetry. I'm going to draw that in right away. Vertical line for our axis of symmetry right there. Okay, plugging it in. Our vertex. Making my XY chart because there's not one here for me this time. X, Y. Vertex 3. Pick some numbers smaller. 2 and 1, bigger is 4 and 5. When you put in 3, make sure you use parentheses again. 3 goes in for X. I'm going to show how to do this one. So I'd have 3 in parentheses squared minus 6 times 3 plus 9. So I'm finding it. 3 squared is 9 minus 18 plus 9, left to right. 9 minus 18 is negative 9 plus 9, that is 0. Oh, 3, 0. So our vertex is on the x-axis. That means there's only one solution. The vertex is on the x-axis. So our solution is x equals 3. Finishing my graph by plugging in the points. When I put in 2, I get 1. 1, I get 4. 1 and 4 again. So, over 2, up 1. 1 away from the axis of symmetry, 1 away from the axis of symmetry. Over 1, up 4. Now I'm 2 away to the left, so go 2 to the right of the axis of symmetry. Drawing my U. And our graph is complete. That's all we have for today. On the bottom, just talking about how we can use quadratics in many ways. Really, one of the most exciting problems is when we start launching something into the air, it usually makes a parabola type shape. Like if I were to throw a football, gravity forces that football to be coming downward and it would look like a parabola. Also works with ballistics as well. Have a great day. Head on over to your Big Ideas assignment and complete your assignment, which is actually in chapter 9 for this one. And have a great rest of the day. We'll check in next week with some more videos.